Let's discuss a scalable and fault-tolerant system design of Instagram. We'll see what all extra steps involved in the post creation part, how timelines are generated, what are the complexities in timeline generation so that timeline access is very fast. We'll see a fault-tolerant and scalable architecture here.
So here I'll be discussing these three major functional requirements of Instagram, or it's applicable for Facebook or any other social media as well. So user can create post with images or videos. User can follow others. User can view timelines, both the home timeline and the user timeline. Next, non-functional requirements. First of all, the system should be highly available. Timeline generation should be very fast with very low latency. So when user will open the app, the timeline should render very fast. It's okay that we are not seeing the very latest posts, but it should render, the page should render very fast. Next, post creation can have lag or it can have eventual consistency. So if I am creating a post now, it's okay if the post is not immediately available to all the users. So it's okay if there is a few minutes of lag between. Data should be persistent, of course, and hot and cold data. So when I am posting something, immediately for few days the post will be very active. So users will view the post, like, comment, and other activity on the posts will be very high. But after few days or after some time, the posts will become inactive or cold, right? So we need to have some kind of archival mechanism for the posts. Next, different types of users. So there will be different types of user. Few user will be very famous. They will have lots of followers. Active users are the users who are very active in the last month or last 1-2 months. Live users who are currently online in the system. Passive user who are not that active in the last month or last 1-2 months. Inactive users, they haven't logged in the system for a very long time. Now, global scale, the system, of course, the system will have very huge scale. Let's have a rough calculation about the scale. So consider there are 2 billion monthly active users, 1 billion daily active users, but not everyone will post every day, right? So consider around 50% posts per day. So that means 500 million posts per day. Now 500 million divided by 10 power 5 posts per second. So if we assume 10 power 5 seconds in a day approximately, then 500 million divided by 10 power 5 posts per second. 500 million is 500 into 10 power 6, then divided by 10 power 5. So that means 5k posts per second. Now timeline access, let's say 1 billion daily active user and they are having 5 sessions of timeline access over the day, right? So for 1 billion users, 5 sessions per day, 1 billion is 10 power 9 into multiplied by 5. So that is 5 billion access per day. So this is just some rough assumption to understand this is a huge scale. Now let's see the few major entities in the system. Of course, we will have a user entity, then the post, the media or asset of the post like the images, videos, etc. Follow, like I am following someone, someone is following me. So this is a follow entity. Next, APIs. See the major APIs in the system. So first one is creating a post. So that will be HTTP REST API. So it will be post/posts, and what it will take the caption or descriptions of the post, the tagline, the media URL. So media upload should happen using pre-signed URL. So if you have seen my system design video of YouTube, you have seen there that we upload media using pre-signed URL in the blob storage, or let's say considered S3. So what we do in brief is services fetch one pre-signed URL from the S3, and it will be passed to the user, and using that pre-signed URL the media is directly uploaded to the blob storage. So we'll discuss that in short. Now let's come to this follow part. So how some user will follow others. So that will be done via this post slash follow with this user ID. Now here this user ID is the user I am following. If I am following someone, this is the followee ID, not the follower ID. Whoever is using this API, that user ID will not be passed here. So of course for any of this API, the user ID is passed in the header section using some JWT token or session token, etc. Right? But here will from the header we'll get who is following, and from this user ID we'll get which person this user is following. For unfollowing someone also, this will be post slash unfollow slash user ID. Next, the timeline, home timeline. For getting a home timeline, when I'm opening the app, I will get the timeline right with lots of posts. So that will be done via this get slash home timeline app. For user timeline, it's the same. It will be get slash user timeline. So this is just the basic APIs to start with. Next, look at the high level design of the system. So of course we'll be going for a microservice based architecture, and we have these services in our major services in our system. We are using API gateway for authentication, authorization, load balancing, API routing, rate limiting and all. So the first service we'll discuss about is the user service, using which user will be able to create their user profile, and the user profile details will be stored in this user database, in this user table. So we'll have the user ID, the name, the email or mobile, the type of the user. So we already have discussed that there will be different types of users in the system: famous, active, passive, live, inactive. But this type of the user can get changed later based on user activity. The created at when the user profile was created, and last accessed at when the user profile was last accessed. Next, we have this follow service, using which user will be able to follow someone, and the follow details will be stored in this follow database using this follows table. It will have the user 1 and user 2. That means user 1 follows user 2, and the followed at when the follow occurred. The primary key of this table will be user 1 and user 2 both combined. And also we need indexes, secondary indexes on both of these columns, because let's say I am one user, there will be lots of scenarios later we'll see that we would want to know who all follows me and who all I follow. So if I want to know who all follows me, then user 2 will be my user ID, then we'll get the people who follows me. And if I want to know who all I follow, then user 1 will be my ID, and then we'll get all the people I follow. So we need a secondary index in both of these columns. Next, let's talk about the post ingestion service, using which user will be able to create a post. Post metadata will be stored in this post metadata DB. This is the post table. We have the post ID, the creator ID who created the post, the caption or description, the media URLs like the images or video URLs, the hashtags, and few other metadata like when it was created and all. Now, the images or videos, the medias or the assets basically will be uploaded to S3 or any other blob storage via this asset service. And this upload doesn't happen via these services, it happens directly. User client directly uploads in the S3 using pre-signed URL. So if you have seen my YouTube system design video, there I have discussed this in detail, why we need that and how we do that. So to brief it here, so if we want to upload the media via this service path, so there will be some delay, and there will be some size limit as well. So what we do when client wants to upload something, we fetch a pre-signed URL from the S3 and pass it to the client. Using that pre-signed URL, client will directly upload the media in S3, and that URL will store in our metadata table. Also, we store the media in CDN, where closer to the user client location, so that client can directly access the medias from their closest location. This asset service also has few other responsibilities, like it stores media with different resolution and size for different types of devices. So different types of users will be using different types of devices with different resolution and format support. So we have to convert the original media into different types, and that will be taken care of by this asset service, and it stores the media in S3 and CDN. Next, we have the timeline or feed service, using which user will be able to see the user timeline and home timeline. So user timeline is straightforward. User's own posts will be there. So in the post metadata table, we have the creator ID. If we can just filter by this creator ID, we'll get the posts for this particular user. Of course, we have to sort and limit the posts, but for a home timeline, we have to do lots of things. So if we want to get the home timeline of user A, so in the home timeline of user A, we'll get the posts from the people user A follows, right? So first we have to fetch the people user A follows from FollowDB. Then for each of the person in the above list, we have to fetch their recent posts. Then we can sort and limit the latest posts for timeline generation. We can also use ML or AI based ranking algorithm to rank the posts, but in this discussion I will not discuss that. So let's say we'll just do fetch the posts for the people user A follows, and then we'll sort and limit that. Now there will be few problems here. The first problem is if the user follows a lot of users, right? Then follows table will return a lot of users, and for each of the user we need to find the posts. So here when the user is trying to access their home timeline, then only we are just fetching all the people this user follows. And if this user follows a lots of user, right, then finding posts for all these users will be a computationally intensive process. And also this post metadata table, this will grow, right? So eventually we have to shard the post table. So that is problem number 2. Post table will grow, and how should we shard the post table? Should we shard it by post ID or user ID? So here we got the people this particular user follows, and for all these users we need the post. So we don't know the post IDs, right? We just need the posts for all these users. So it makes sense to shard this post metadata table by user ID. But then we have to aggregate the data. Let's see that here. So let's say user A follows user B, C, D, and we need posts from user B, C, D, right? So if this user B, C, D, they are in different shards, then this we need an aggregator here that will fetch the posts from all these shards and it will aggregate there. So we need some extra overhead for here. There is some solution here. If we can pre-populate this feed in cache on post, right? So here what we are doing earlier is in the timeline or feed service, when the user was accessing the timeline, then only we are doing all this computation. Instead of that, what we can do is we can pre-populate this feed and store it in timeline database or feed database and in feed cache. And in feed cache, let's say how we'll store it. Let's say this is the user 1 and these are the posts. For this is user 2, these are the posts. And this way we'll store it. Now how it will work? So when user A posts, we'll find people who follows A. Then for each of these people's feed, we'll add that post ID. So earlier what we are doing is when some user is trying to access their home timeline, then only we are doing all these computations. And now we are doing the opposite. When someone is posting, then we'll be finding their followers and will update their feed. So I have improved the design here. So let's say when the someone is posting, this post ingestion service will send the post ID and who posted this to this timeline and feed service. And this feed service will find the followers of this creator. And for each of these people's feed, it will just add the post ID. Simple. So now, what if this user is followed by lots of people, right? So then on post right, we have to find followers of the creator, and for each followers feed table we have to update, right? But that's a lot of work if the user has lots of followers. So one solution can be, we can have an async flow, because it's okay if the timeline doesn't have the very latest posts, right? So timeline should render very fast, but it's okay if the timeline is not having the very latest post. If it is taking a few minutes of time to get the latest posts, that is fine. So we are having an async flow now. So when someone is posting, this post ingestion service is storing the post metadata in post metadata DB, and also the assets are updated. Along with that, it's also writing in this post topic, in some Kafka topic, let's say. And there will be some post workers that will read from this post topic, and then it will do all these tasks. It will read the post, it will find who is the creator, and it will fetch all the followers of that creator, and for all of these followers feed, it will update with that post ID, the DB and the cache. Now, will it be enough? So it will be good for people, normal people who have lots of followers. But if the user is a famous one who is posting, suppose some celebrity posts, then the post workers needs a lot of throughput there as well. So it will not work for a famous people, a famous or celebrity. Now that is also can be configurable, like after how many followers someone can be considered famous. So we can make it configurable. So now what will happen for the famous or celebrity users? This async flow also will not be enough. So what we can do, we can have an hybrid approach. For normal people, will use this feed update on the post right. When someone will post, it will go via this path. For famous people, will fetch their post on view timeline call. For famous people, let's say I am accessing my timeline. In the timeline service, will find out which all celebrities I follow, and their feeds, their posts will be fetched when I am accessing my timeline. That is on read time. So this is called this two path, like fan out on write and fan out on read. So for regular users, when someone posts, their followers timeline caches are updated with a pointer to that post. For famous people, fan out on read, that is when you open Instagram, it fetches recent posts from famous people you follow, and that is on demand. So this fan out on write and fan out on read, both will be using in our system. So this is a hybrid approach. Now one more thing is, there are not only famous and normal users, so there will be the other kind of users we already discussed, right? So let's see how we'll handle the feed generation for this type of all these types of users. For famous users, followers feed generation will be on read time. For active users who are active this month, will populate feed cache on post write. For passive users, like they are not active this last month, we can ignore generating this feed cache. We can update the timeline DB, but we no need to update the feed cache. For inactive user, they haven't logged in for a long time, so we don't need to generate feed for those users. For live user who are currently online, so we have to populate the feed cache for them, and also we have to send live updates via WebSocket. So that is the next thing we'll see now. Now how do we inform live users? So consider there is one user, this is the live user. So first time when this user accessed the app or timeline, the request came here in the timeline feed service, and the timeline is fetched from this feed cache. But the user is online, user is on this page only, so the latest post needs to be fed to this live user page via this WebSocket connections. So we are having lots of WebSocket handlers, and different live users might be connected to different WebSocket handlers, and there is this WebSocket manager who can keep this mapping in this cache, like user 1 is connected to this user 1, handler 1, user 2 is connected to handler 2, and all. Now the post workers, when updating the feeds, along with that, for the live users it will update the posts via this WebSocket handler. So for this user ID, this is the new latest post ID. The user is live, this new latest post information is directly fed to this user's page. So this is how live users will be informed about the latest posts. Now next, hot and cold posts. So of course, let's say I am posting something immediately for a few days, the post will be very active, very hot, right? But after few days or after some time, the post will become cold, and not many people will be viewing, liking, or commenting on those posts. So what we can do is we can have some LRU policy for this feed cache. So after some time, we'll remove the older posts from this user's timeline feed. And also there will be some archival service. It will read from this timeline or feed DB, and the older posts will be moved to this archival database after a few days. After a few days, we can remove media from CDN as well, because the media also will not be accessed much, right? If the post becomes heat again, we can again move the media back to CDN. Next, talk about the verified posts. So Instagram, Facebook, or any other social media, of course, will have some content moderation. So it will check for few things for the content. Like I have mentioned few examples, like media should not be corrupted, there should not be any malicious characters, nudity or sexually explicit content should not be there, hate speech, racism or harassment, violence, misinformations. These are few things. There will be lots of other things this apps will be checking, but I have just given few examples. So let's say this post injection service was writing in this post topic, right? Then after that, we have some verified post workers. So that will read from the topic, it will do all these verifications, and then the verified post will be sent to this verified post topic. And there will be this post workers. So the post workers we already discussed, that will be reading the verified post from this verified post topic, and the rest of the flow is similar. It will fetch the followers of the post and it will update the feed. Next, we'll discuss about feed personalization. So that is, user will have some interests. When the user is creating the profile, then also they can provide few interested topics, like I'm interested in this topics, and I should see this type of posts more in my timeline. So let's say this user provided interest, we are storing here in user provided interests. There also will be some system generated interests, that is based on user activity. The type of posts user is creating, the type of post user is liking, commenting on, and other based on other activities, we can decide like what all users actual interests are. These are the system generated interests. So liking, commenting part we are not covering here. So let's say only based on the user posts, the type of post the user is creating will decide what is users interest, and will show this type of post only to the users. So let's see how it will work. So after verified post worker, this verified post topic, we have this verified post topic where the posts are coming, right? So let's say after that we have some analytics workers. It is reading from this verified post topic, and it is running few analytics algorithms, heuristics based or MLAI based algorithm to understand the content of the post, and it is adding some tag or category to the post. Then the processed posts are added to a different topic. From there, post workers is reading the post and doing whatever it was doing earlier. Now, post workers were doing what? Post workers were finding the followers of the post creator. This is the page followers part from the follow DB. After that, it will filter followers whose interests match with the tag. So all those followers, it will not update the feed. It will just filter the followers whose interest match with the tag, and that will be, let's say, will be storing in some cache. So this user database was storing this user provided interest, system generated interest. In this cache, let's say we are just storing few things like user ID, user type, interests, and last access at whatever. And based on that, it will do the filtering. Now, the question will come like how the system generated interests are populated for a particular user, right? How do we know that this user is interested in this topic, right? So, user provided interests are fine, that user explicitly has provided to us. But based on their post generation, we have to find out their actual interest, right? So let's say there is some user profiling service. It is reading from this processed post topic as well. Here the posts having the post content along with the tag and category, right? And based on this tag or category, it will decide the user's interest. So let's say it will run some Spark screaming job on Hadoop cluster, and based on the tag or category of the created post, it will update the interest for the user, the system generated interest. So that's it. I think I will discuss more about this profiling personalization part when I'll be covering my ML system design topics. But for now, this is it. Now all the services here will be auto scaled and with proper load balancing and all, so that we can handle the load properly and the system is highly available. There is no single point of failures. The database will be sharded properly, and let's see now if we have covered all the functional and non-functional requirements.